Hi, in this video you'll see that Vedic mathematics is not just a collection of tricks, as some people think, but a complete system of mathematics. So suppose you want to multiply two numbers, 21 by 23. In the Vedic system we use a simple pattern, and it comes under the formula vertically and crosswise. First we multiply vertically on the right here. 1 times 3 is 3. Then we multiply crosswise, the 2 by the 3 and the 1 by the 2. 2 times 3 is 6, 1 times 2 is 2, and 6 and 2 add up to 8. Finally, we complete the pattern by multiplying vertically on the left. 2 times 2 is 4, and there's the answer, 483. So we got the answer in one line using this simple pattern. And it's easy to understand how it works, because to get the first figure we multiply units by units. That gave us 3 units. To get the tens, we multiply tens by units and units by tens. So that cross product automatically gathers up all the tens for us. And then we multiplied, in the third step, we had tens times tens, which gave us 4 hundredths. Tens times tens gives hundreds. Well, that was a very simple example with no carries, just to illustrate the pattern. Let's do one with some carries. Again, from right to left, we have 3 times 4 is 12. So we put down 2 and we carry 1. Now we do our crosswise step. So we multiply the 3 by the 4 and the 3 by the 4. So we have 12 and 12, which is 24. And with the carry, that's 25. So we have 25, we put down 5 and carry 2. The third step is vertically on the left here. 3 times 4 is 12. And with that 2 we carried, we have 14. So there's the answer, 1,452. If you compare this with the conventional method, you'll see that it's very much easier. We don't have the 2 steps of working that we normally have, and then the answer at the third step. This is using a simple pattern and gives the answer in one line. In fact, we can multiply numbers of any size in one line using this formula. Now I'm going to multiply these numbers together, but from left to right. So I'm going to start at this side. But first, let me point something out. When we did our first product here, we said 3 times 4 is 12. And that 1 in the 12 was actually a 10, but it was counted as 1 unit in the next column. So it was counted as 10 times smaller. And the reverse happens here. Any carry becomes 10 times bigger, as you'll see. So first of all, we multiply vertically on the left. We have 3 times 4 is 12. We put down 1 and carry 2. Now that 2 counts as 20 at the next step. Every carry is 10 times bigger when you're working from left to right. The next step is the crosswise product here. So we have 12 and 12, which is 24, the same as before, 24. And to that 24, we add 20. This is counted as 20. 24 and 20 is 44. So we put down 4 and carry 4. The third step, of course, is the vertical on the right. That's 3 times 4 is 12. And that 4 is counted as 40. So we have 12 and 40 is 52. And there we have the same answer as before, 1452. So we can go from left to right or from right to left. And this is reversible too. Given the 1452, the answer here, and the 44, we can find the missing number, and that's equivalent to division. It's equivalent to dividing 1452 by 44. So this simple vertical and crosswise pattern is reversible to do division. And it's a general method too, gives the answer in one line. Now look at the 14 at the beginning here, and look at that 4. What number goes above the 4 there, so that it accounts for that 14 or most of it? Well, it must be a 3. 3 times 4 is 12, and that's 1200, and we've got 1400, so there's actually 2 left over, which we can prefix to that 5 to make 25. So actually we've got 252 left for the next 2 steps. Now think of 25 in the tens place. 25 in the tens place. That's formed from the 2 cross products here. That cross product is 12, and if we take that 12 from the 25, we're left with 13. So this cross product must give us 13, or something nearly 13. And it must therefore be a 3 there, because that will give you 12 and accounts for all but one of that 13, and so that one is left over. And then vertically on the right here, we have 3/4 of 12, which is exactly what we've got, and so the answer is exact, it's 33. Had this 2 been a 3 here, we would have had a remainder 1, and we could continue the division if we wanted. The same thing applies for multiplying algebraic expressions. In the conventional system, you have a different method for multiplying numbers as you have for multiplying algebraic expressions. But we're going to use exactly the same pattern to multiply 2x plus 3 by 3x plus 5. So vertically on the right here, we'll do this from right to left, we have 3 times 5 is 15, so there's 15. Next we multiply crosswise, so we have 2x times 5, which is 10x, 3 times 3x, which is 9x, and 10x and 9x is 19x. That's the crosswise. Now we have vertically on the left, 2x times 3x is 6x squared, and that's the answer. And we can multiply expressions of any size together like this, and in fact the method is even more spectacular if you have longer expressions, because it automatically gathers up all the like terms for you. So there's only one step. And this too is reversible. Given the 6x squared plus 19x plus 15 and the 3x plus 5, we can find what we need to multiply the 3x plus 5 by to get that quadratic. In other words, we're dividing the quadratic by 3x plus 5. So looking at the 6x squared here and the 3x, what goes above the 3x to give you 6x squared? Well, it must be 2x. That product gives you 6x squared. Now look at the 19x here. That's formed from the two cross products. We've got 10x here so far, so that leaves 9x. So the other product must give you 9x. So that must be plus 3. 10x and 3x is 19x. And then 3 times 5 is 15, so that's an exact answer. We have 2x plus 3 exactly. If this 15 had been 20, we'd have had a remainder of 5, and we could continue the division to divide that 5. So we've seen here we can multiply numbers of any size in one line. You don't have lots of steps of working, but just one line in the Vedic system. And although the vertical crosswise vertical pattern that you've just seen can be used to multiply numbers of any size, the pattern itself can also be extended to multiply numbers and always get the answer in one line. And then there's a simple pattern that makes it easy to remember. You're less likely to make mistakes. It's easy to explain, as you saw. We can multiply from left to right or from right to left, whichever you like. Left to right's better for mental calculations. And it's reversible. So the same method we use for multiplication simply reverses. Everybody knows that division is just the opposite of multiplication, but that's not at all obvious from the conventional system. You've got an ugly method of multiplication, an even worse method for long division, and there's no connection between them in the conventional system. But in the Vedic system, you see how beautifully connected they all are. And our divisions are, of course, in one line. Algebraic products, we can use exactly the same pattern for doing algebraic products, and that too is reversible. Similarly, the multiplication pattern simplifies for squaring numbers. And this is reversible as well, so that you can do square roots in one line. Once you can do square roots, you can solve quadratic equations. If you're finding the square root of 7, say, you're solving the equation x squared equals 7. And this can be extended for general solution of quadratic equations and also higher order equations. So this vertically and crosswise formula has lots more applications. In fact, we can use it in trigonometry and calculus and so on. And it's one of 16 Vedic formulae. And we might just ask, how is it possible for 16 formulae to govern all of mathematics, which is what Vedic mathematics is? Well, just as your physical body has specific functions like walking, eating, and so on. Your mind too has specific ways of working. We reverse our thoughts. We can combine and generalize ideas. We spot analogies, and we hold something in mind while we do something else, and so on. There may be 16 of these. And since the mind creates the math, it isn't surprising that there could be just 16 basic ways of using the mind to do math.